Okay, welcome back. We are going to continue with the angle bracket. At this time, we're going to be creating the drawing for it. And like other drawings in the past that we've done this year, this is going to follow the same procedure. The only difference is I introduced angles. So we'll be calling out angles. And then there's additional complexity compared to the geometry that you've been used to. And also we are calling out a metric unit as opposed to the imperial units we've been doing in the past. So first you're going to click File New. You're going to select Drawing, click OK. Select ANSI A Landscape. Once again, if you're ISO, switch the check mark and make sure you select ANSI. I know there's some computers out there that are pre-configured. Say OK. And at this time, once again, we're going to click the blue circle after we've checked to make sure that angle bracket is what's specifically open and visible here. Now, I called my file angle_bracket. Hopefully you named your file something logical as well. We're going to click Next. We want multiple views. Click, click, click. At that point, you have your views. You need to take a look at your scale and ask yourself, do these views look appropriate? Hopefully at this time you've identified that they're too big. So we're going to use custom scale. And let's see what half scale looks like. Half the size. It's kind of tiny. So you could play around with these a fifth the size. Like I said, this is half the size. This is the full size. Twice the size, and so forth. None of these will work for us. So we're going to go back to 1 to 2. It's too small. 1 to 1 is too big. Unlike traditional ratios, we can scroll up and supply a decimal value. So 1 to 1.5. It looks appropriate. And at this time, once again, scale is not that big of a deal. We're going to learn in the future lessons related to architecture and maps how scale is very important. Due to the fact that we're pulling dimensions out and calling things, this is not that big of a deal. So find a scale that seems to suit your needs. So for this unit, make sure you're doing 1 to 1.5 under user defined. We have our 4 multiple views. Once again, this is our model view property manager. We're going to say OK. And then we have our views. We have our front. And if you can remember the drawing that we were referencing in the past, this is the front. So at this time, we're going to dimension these things. At this time also, it might be, if you were doing this by yourself, it would be good to have something like this on your desk so that you can look at what was called out initially that you used to create the model. With enough experience, you're not going to need this, and you're going to be able to think for yourself and decide for the reader what it is that they're seeing. At this time, I would say your experience is not quite there for that. Okay. There's no hidden geometry that can be seen. The back hidden shelf right here is obstructed by the front hidden shelf because they're directly in line with each other. So when the hidden line is on, this solid line that's over the top of it masks it so you can't see it. So there's no need to really create any hidden line views because you can't see them even if you turn them on, because this rectangle that's on a slope is directly in line with this one. So if we turn on the hidden lines here, you won't see the shelf that's here. Okay, what you do see though, what you do see here is the upper shelf region right here. That point represents these lines here. That's the bottom point to this line. And the top point is this top line. And then from this line to here, on the back side, it's a slope. All right. So hidden lines here, nothing visible except for the underneath shelf. All right, that's this point here. The blue circle, the blue dot represents this line here. And this point here is represented by this dotted line here. Okay? And this view, even with hidden lines, you can't see it because the hidden shelf behind this shelf is directly in the same position. Let's switch this to shaded with edges. Can move this over to the side just to kind of show that it's not necessarily part of the the three initial views. And now let's call out widths, heights, and depths along with angles. This is a good spot to put the angle because I can see it. This is a bad choice, and this is a bad choice. So the angles are going to be called out on the front view. And the front view, we could tell the user who reads this how tall this part is or how wide this part is from this view. This view, I can tell someone how tall the part is, just like the front view, but how thick or deep the part goes from the front edge, which is this, or this line, to the back edge of the part, which is this part. So height and height share commonality, but depth is this, which is the same as this. So I can do width and depth, height and depth, height and width. Okay, so every single view can do 2 of 3 dimensions. It's up to you to decide later when you're thinking for yourself which views work best for what dimensions, heights, widths, or depths. But it's best to group them together if you can. It's not always possible. However, it's a drafting convention. It's not a standard that you have to follow blindly. It is something that you try to observe. So I'm going to look at the widths, and I think I can easily put heights here. Actually, I'm going to put depths here. I'm going to put widths here. I'm going to put heights here. I think we should be in good shape. So we have an overall we can call, and a couple other steps. So let's see if this gets messy. Overall. Now we drew this in millimeters, didn't we? It's not in millimeters. How did that happen? It's supposed to say 96. And the reason why is even though if you've drawn the model in millimeters, geometrically it could be measured in any unit. So currently the unit measurement is set to inches. So even if you've drawn a model in any specific unit, you can create a drawing in other units at that point. So we're going to switch this to MMGS, and there's our 96. Okay. So at this point, we are going to have to call out this step. That step's the same. But we have this width here. We have this width here. Okay. We also have an angle that, once again, we're going to try to call out somewhere. We could also put this down here if necessary. If we can avoid it, we try not to put dimensions in what they call the gutter around the border of the title block. We can have it inside. It would be ideal. So as I said, I don't practice or rehearse these drawings. I'm just shooting off the cuff. So I wanted to document the proper process of going through this, even if I make mistakes. I want you to see how I think so you can start to think like me. So I think I want to do what they call the baseline dimensioning technique. But it's going to create a lot of dimensions that might make it difficult to create the angles. So we'll find out. And we can undo this if we have to. So baseline means we're going to choose this as our baseline. And we're going to kind of keep running out to the next point, then back to the baseline, next point, 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 back to the baseline, and so forth. And then you can add or subtract any of these numbers to get any measurement you want. But you're going to find out that it's kind of messy, and we might not need to do that. So I'm going to click, This second vertical line, place it back to the baseline, to this point, back to the baseline, point, back to the baseline, point, and click OK. Right click, select your select tool. Let's move this up a hair. And as you can see, I have a baseline, which is here, and I've dimensioned my way out. And it looks neat and organized. I can find out the distance from here to here. I can add all of these up to get anything to be used as a sum to be subtracted from another value, and so forth. So if I wanted to know this distance, or the length of this line, I would take 60 and subtract 36 from it, and what would be remaining is this. Does that make sense? So let's just so you can see it happen, I'm going to pull up a calculator. Okay, we have 60 minus 36, and there's our 24. And if I show you our source document, there's the 24. So baseline dimensioning does work. And if you get stuck, this is a good strategy to make sure you've covered all your bases without having to second doubt and question yourself. And it's short and sweet. It requires a little bit more work for the reader to extract dimensions. So I'm going to undo this, or Windows select my dimensions, delete them, and try to approach it in a different way. And then I'll consider which one looked better. I know that there was plenty of room over here to specify angles. So the baseline worked. And if you notice, I only did half because this part is symmetrical. And if you only show half the dimensions in a baseline dimension, you imply that this is a symmetrical part. Because whoever reads this is going to assume that a professional did this correctly, and the reason why they left off the dimensions is because it is symmetrical. They're not going to assume that a student did it and decided to just stop working. Okay, so we haven't really gotten anywhere, I know that, and I apologize this is long-winded. Let's do the 16. So now what I'm going to do is the other approach is I'm going to look at what was used to create this model. And I'm going to try to call out these numbers and ask myself, do I really need to know these numbers? So if you have a source document, you could definitely use this as a template of what you need to call out. I just did the 16. I could do the 64, and then the 10, and then the 10. Then I have this 24, then I have this 20. So once again, this was kind of designed to be shown for you in 3D. So there's probably more dimensions on here that's necessary. So we have our 16. See how the 10 looks. This is sloppy. Rapid dimensioning thought that this was a good idea. It's not. We have an overlapping dimension on top of a leader line, and that is not allowed. So you could just drag this over to here. That could be confused as 16 tenths. There's enough room to fit this here, so just click and drag it. Zoom in though, because if you don't zoom in, you're not going to get these small snap drag points. If I zoom out and do something like this, it's a little more difficult to kind of get it into the right position. So you zoom in, you'll have greater depth of accuracy for dragging your points. You can even put it here, whatever works. That looks good. Okay, we have our 16, our 10. We can call out the angle here, so we don't need to know the distance here. We can call out our 24. I don't particularly like how these are overlapping, so maybe bring this up. It'll snap and line up itself with the 16. And I could specify this 10. I'm going to drag this over here, keep it lined up with the 10 over there. And now I could show the 16. However, that wouldn't be useful. They'd have to add 16, 10, 24, 10, 16, and they still wouldn't get the overall. So it's not helpful. So at this point, I'm going to do the 96. Shoot that up. At that point, we should be able to call out a 45. And this is the tricky part. We have these nice dimensions, and now we have to squeeze an angle in. So let's try going from here to here. 2 lines. Drop the 45. Now this, you do not want dimensions to cross over the part if you can help it. So we could bring this in. We could do something like this. No dimensions are kind of overlapping. I mean, we have this, but that's something we can't avoid. It's not over the part. I can see that it's this line to that line, and it is 45 degrees. Let's see if we can create that over here. So if you can see how I'm having difficulty dragging, it's creating the measurement point between here. I'm going to press delete, just get rid of it. It has to do with the order of which I click the lines. So I got this one first, and then I did that one, and now I did this one, and then I got that one second. See if there's a different result. And there is. And you could see that those are aligned with each other with the yellow line. I can let go. I don't like this. I'm going to move this over a hair. And move this in a hair. I still don't particularly like it. Move this up a little bigger. I'm just thinking at this point, I'm going to leave it. Baseline dimensioning would have worked. But I kind of like this. This, I think, would be easier for someone to read to make this part rather than add and subtract all these variables. They can look at these numbers. So there's all of our widths. We have 16 on the shelves. We have our 10s. We have our angles. We don't have our heights. That's going to be over here. And I'm debating. Let's call this out. It's not going to hurt anything, and it's definitely going to add a piece of information that isn't available without this. Let me explain. We did not call out the horizontal distance between this point and this point. All we did was specify an angle. So from this point, I can go 16, I can go 10 over, and from that position, I can shoot a 45. And then from that point, how would I know where to put this? I know it's 24. So if I take 16 plus 10 plus 24 plus 10 plus 16, and I subtract that from 96, I'll be left with a value that can be divided in 2, and it would represent the distance from this point and this point. And anybody reading these documents would be able to figure that out on the professional side. So I don't know the number off the top of my head. Let's do it. 16 plus 10 plus 10 plus 16 plus 24 is 76. So this time you're saying, okay, obviously at this point, the difference is 20, right? 96 minus 76. And then that is the combined lengths of here to here, horizontally speaking, right here. And we're going to divide that by 2 because it's for this one too. So when we divide it by 2, we now know it's 10. So that might be helpful for somebody. So this didn't clutter it up. There's a lot of numbers. However, as I said, this part is a little more complex than what we've done in the past. I don't like these angles. I don't like where they are. However, we're kind of left with what we have to deal with. There's still numbers that we have to call out for the 45 on the inside. Okay. We could probably take one of these out to imply that this angle and that angle is the same. So I'm going to do that. And now I'm going to click here. Now I could do this and get an inside angle. Drag it. Could do something like this. It's just kind of... That would work. I don't like it. It's kind of ugly. Let's delete it. Let's try something else. Let's do this line to this line. Now we have the opposite. Right? We have the other side of that angle of the 180 degrees. Right? So here, this would work. I don't like it at all. So it's a battle to where you're going to put dimensions sometimes, especially, like I said, when you're thinking for yourself and you're trying to create a drawing of a part that you've made uniquely to you. I'm going to go on the inside. I want to make sure that the arrows are clearly pointing to the angle that someone will need to read. So I'm going to do this right here. So we have a little bit of a line sticking out. Line sticking out here. I don't like the arrows where they are. Move my 45. It's kind of in the middle. You'll see where I'm going with this in a second. And we've only done this one other time in the past. We're going to switch to leaders, and we're going to tell our arrowheads to go inside. That looks a lot more readable at this point. So our front view is done. Let's take care of the heights. The other views are a little simpler, so this is going to go faster. We've done the majority of our video. Heights. So we have our total height. So bottom edge, top edge, shoot it to the left. There's our 50. We need to know this guy. Click it, shoot it out. We'll arrange these if necessary moving forward. I may need to change the drafting standard too, because I realize I'm not an ANSI. This number's reading vertical. So let's go to Tools, Options, Document Properties, and for those of you that already know you're an ANSI, don't worry about this, but every time you come here and it's already ANSI, then you know who you are. Just don't come here. But for the most of you, you're going to have to. Now my dimensions look better in some ways, and if you look at my front view, worse in others. So now this 45 degree is giving me a hard time here. There's no need to show two decimal places. So I'm going to click on this, and I'm going to use now the features of changing decimal places. This is just 45. We don't need any decimals. Just say none. Over here, say none, and that's under the Value tab. It's going to give us more space that we have limited area. Okay, so it's not perfect. Maybe this is a good opportunity to shoot the arrows to the outside of this one. So let's go back to leaders, switch it to outside, take a look. Maybe move this down a hair. Yeah, I guess that's the best as we're gonna do. So let's leave that. Let's go back over to our heights. And we have our 10, our 50. We're gonna need to know, right, from this shelf to the bottom. So we're gonna go here, here, shoot that out. All right, now the remaining, right, from here to the top, that's not necessary because we can do some subtraction. Right, we can take 50 and subtract the 26 from it. So we know that this is 24 without having to call it out. This height is not necessary because we know depth-wise it's down 19, and then from that 19 on that edge is just 45 until it hits the wall, so not necessary to tell me how tall that part is. So in terms of heights, We just have one more dimension to call out, and that is the shelf to the top. I'm just going to drag this over so you can see this. Okay, so this shelf, I'm going to switch this to select. You don't have to do this. It's just for explanation. I'm going to drag this over so you can see this for a minute. You can see that this dotted line represents this shelf. That's why these drawings are next to each other. So you can see how they are projected over to the other view. So this dotted line is the shelf. The next dotted line is where the angle starts to protrude up to the top of the part. Okay, so now that you know that, I'm going to try to pull this over and back to where it belongs. And we need to supply a measurement from here to here. So they know that from the top down, it's a specific amount to get to this shelf. Okay, so we're going to go to Smart Dimension. We're going to hit the top of the shelf, or top of the part, sorry, to the top of the shelf, and bump that out. Okay, so that's 16 down. So from here to here is a vertical distance of 16. This 26, I don't like how the arrowheads are pointing out. Kind of confuses things. We're going to go to Leaders and switch it to the inside. This 10 is okay. The leaders, or the arrowheads, cannot be on the inside. It would be cramped. This 16 should be okay. Might confuse somebody that doesn't have experience, because reading this space might imply that it's measuring from here to here, but it's not. Might be confusing. I don't know if this is going to look good. Let's just see if it looks too cramped. I can also do this. So now it doesn't look like it's a part of that other dimension. So I have our 16, our 50, our 26, and our 10. Early on, if you're trying to check and think for yourself, I would look at this and say, okay, I got a 10, 26, and a 50, a 16. Is there any other heights on this source document that is necessary to be called out that they did? No. So we're going to switch on over, and we're going to do, okay, we have widths here, heights here, depths. All right, so at this point, we're going to do the overall. Shoot that over. There's our 48. We're going to also have to do, let's see here, this distance from this line to this line. That's our 6. Leave them where they are at the moment. We can adjust later. Okay, so let's go from this line to this line. There's our 36. 36 plus 6 plus 36 will be 48, so we don't need to dimension this line to this line. We do have some other pieces that we need to call out. Would be from here to here. That's our 19. The 6 makes things difficult to understand. I'm going to delete it. Maybe we can call it out on the other side. 19's good. And then here to here, we need to know that's 10. Okay, that's this part. 19 down, that's from here to here. 6 that we just got rid of is from here to here, and obviously 36 is just the inside, or this part right here. So let's just do here, here. This is an exception. It's kind of in the gutter per se. I'm going to move this over. A little crowded. I'm going to move this view down, right click, select, click, drag down. I apologize, we're going about into 30 minutes of this. However, like I said, this is a complicated part. We have our angles, we have our depths here, we have all of our widths, and we have all of our heights. With width, depth, and height combined, we get our three-dimensional part. At this time, I believe we have finished. However, there's one piece of information that the drawing is calling out, is the malleable iron. Rather loose term. We're going to type that in. MATL is material. So let's type that. We're going to go to annotation. Note. I'm going to put my mouse over and I'm going to touch it. If you touch a part or anything, an arrow with a leader line will appear. If you don't touch anything, like here, you can type your name. All in uppercase. Say OK. Put it here. Now I'm back to annotation. Let's touch the part. And I'm going to maybe put it down here. And then all in caps, so put your caps lock on. MATL hyphen MALLEABLEIRON. Enter. Oh, not enter. Sorry. Click off. And then press escape. If you end up clicking and placing a couple more of these strings of text, you could just click on them and press delete and they'll go away. Okay, this part's done. So at this time you want to snip this, save this as an image, create a web page as I specified in the Google Classroom, embed the image into that page, and then turn that page into the Google Classroom. Have a great day.